Hello, in lecture number 6 of diode and their application, these are some outlines of lecture number 6. First one is the full wave rectifier, second one types of full wave rectifier, and third one advantages, disadvantages of center tap full wave rectifier. What is the meaning of full wave rectifier? We already studied that half wave rectifier. In half wave rectifier, only one diode is used for conductions. Now we will study the full wave rectifier. Full wave rectifier are classified into two types: bridge rectifier and center type rectifier. In center type rectifier, there are two diodes are used. In center type rectifier, there are two diodes are used, and in bridge rectifier, there are four diodes are used. What is the meaning of full wave rectifier? Full wave rectifier converts both positive as well as negative half cycles. Is nothing but half wave rectifier is only conducts for positive half cycle. It is not conduct for negative half cycle, but full wave rectifier conducts both positive as well as negative half cycles. Basically, rectifier is used to conversion of AC into DC. DC is nothing but your pulsating DC. It provides double output voltage compared to the half wave rectifier. A full wave rectifier is made up of more than one diode. In full wave rectifier, there is a two or four diodes are present, such as in center type rectifier two diodes are present, and in bridge rectifier there are four diodes are present. Now, what is the meaning of center tap rectifier? In this is the connection of center tap. This one is the center tap rectifier. Here output is input is applied to input side, but the output is taken across the secondary side, and in secondary side there is a common terminal center in between this output side. So this there is a two parts are present. Here is the output is taken across positive with respect to this reference and negative with respect to this reference. See here, a center tap transformer is a dual voltage transformer that has two inputs I1 and I2 and three outputs. Center tap having a two inputs I1 and I2 but three outputs T1, T2 and T3. The T2 terminal is the connected to the center of the output coil, which acts as a reference ground or 0 volt reference. It is acts as a reference or 0 volt ground. 0 volt ground. The T1 terminal produces positive voltage and T3 terminal produces negative voltage with respect to the T2. See here, T1 terminal produces positive voltage and T3 terminal produces negative voltage with reference to T2. The design of center type rectifier is as given below. This is the construction diagram of center type rectifier. In this construction diagram, here is apply the input, and input is nothing but your AC supply. This AC supply is applied to the center type transformer, and here the in center type transformer there are two diodes are used, D1 and D2, and output is taken across load resistance RL. This is the construction diagram of center type rectifier. See here, in construction diagram of center type rectifier is that the circuit diagram of center type rectifier is as shown in figure. Center type rectifier is basically consist into center type rectifier is basically consist into center type transformer, two diodes, center type transformer, two diodes and load resistance RL. Now, working of this center type transformer. In this working, during the positive half cycle, the T1 is positive with respect to during the positive half cycle. This one is the T1 terminal, this one is the T2 terminal, and this one is the T3 terminal. This one is the T3 terminal. During the positive half cycle, T1 is positive with respect to T3. T1 is positive with respect to T3. So, T1 is positive with respect to T2 or T1 is positive with respect to T3. Both having a meanings are same. So during the positive half cycle, T1 is positive and T3 is negative, as well as T2 is also a negative. So diode D1 is acts as a forward bias. Why diode D1 is acts as a forward bias? Because in diode D1 having this terminal is the anode terminal, this one is the cathode terminal. So anode terminal having a positive charge, cathode terminal having a negative charge. So this T1 terminal having a positive charge, this positive charge is connected to positive and this negative charge is connected to negative. This negative charge is connected to negative with through the load resistance RL. So this diode is D1 is acts as a forward bias and diode D2 is acts as a reverse bias. Why D2 is acts as a reverse bias? Here is the anode terminal. Here is the anode terminal. Anode terminal having a positive charge, but this anode is connected to negative. So there is a reverse bias connection takes place. In reverse biasing, positive is connected to negative and negative is connected to positive. So diode D3 is acts as a reverse bias. Diode D3 is acts as a reverse bias and output is taken across load resistance RL. Output is taken across load resistance RL. See here, this is the output, this one is the output. This is the positive half cycle. In this positive half cycle, T1 is positive with respect to T2 and T3. So diode D1 is acts as a forward bias, D3 is acts as a reverse bias. So only positive half cycle present across load resistance RL. So in this circuit diagram, diode D1 on and D2 off condition. Diode D1 on and D2 in off conditions. Now during the negative half cycle, this one is the negative half cycle. During the negative half cycle, this T1 is negative with respect to T3. This T1 is negative with respect to T2 and T3. So diode T1 is acts as a reverse bias and diode D2 is acts as a forward bias. Diode D2 is acts as a forward bias. Why? Because forward bias, this having a positive charge and this positive charge is connected to positive, this negative charge is connected to negative. So diode D3 is acts as a diode D2 is acts as a forward bias and D1 is acts as a reverse bias and output is taken across load resistance RL and this one is the output is taken across load resistance RL. Here the diode D1 in off conditions, and diode D2 in on conditions. Diode D2 in on conditions. See here, now during the negative half cycle, T1 generates a negative cycle and T2 will generate a positive cycle. This will put the diode D1 into reverse bias and diode D2 in forward bias, but the polarity across the load resistance RL is still the same as the current takes the path from T3 to T1 as shown in figure. So this is the final waveform of center tap rectifier. This one is the positive, this one is the input waveform and this one is the output waveform. In positive half cycle, diode D1 is acts as a diode D1 is on and D2 is off, and during the negative half cycle, diode D1 is off and D2 is on. In this way, we will write here D1 on, D2 off, D1 on, D2 off, and writing here is same as it is. Now these are some advantages of center type rectifier: low ripple factor, high rectifier efficiency, low power loss, and these are some disadvantages of center type rectifier. Center type rectifier cost is very high. Two diodes are required for the simplifications and complicated construction because of center type transformer. Circuit is complex. Why circuit is complex? Because here the center type transformer is used and center type transformer is heavy, as well as center type transformer is the highly cost and it requires the two diodes. If any queries related to this lecture, then you will ask me.